So we'll understand what is an hash map. And we'll take up some exercises in today's class. So we'll understand what is an hash map here. So we'll see this. So I'll explain hash maps and the internal working of hash maps first. So what is an hash map? That is our discussion. What is an hash map? We've already learned list, linked list, and array list. Say a hash map is used for storing key value pairs. So what is that you're going to store using hash maps? Key value pairs. So can I take some examples for key value pairs? You can say registration number, say 12BC001, and value is, say, I'll give my name Satish. So this is the key, this is the value. Likewise, you can have more key and value pairs. So BCE002, RAM is the value. 12BCE003, say Jeff is the value. So you have a key and you have a value, and you want to store such data. You think about hash maps. And we have to understand how hash maps stores this data internally. That also we have to understand. But before going into that, the very important property is keys cannot be duplicates. So can you have a duplicate registration number? No. So key cannot be duplicates, but value can be duplicates. For two different registration numbers, the name can be the same. So key duplicates are not allowed. Values you can have duplicates. So that is one of the important thing. And in hash maps, there is no insertion order maintained. There's no ordering. So these are the differences. When you think about linked list and hash map, these are the differences. Okay. So next comes the strategy. How hash map stores these values. How hash map internally stores the key value pairs. So when you talk about hash maps, it's nothing but an array of objects. That is an hash map. It's an array of objects. So what is there inside this array and what is the minimum size for this array is our next question. So let's say whenever you create an hash map, the initial size of the array is 16. So you create an array of size 16. It's an array of objects. Let me draw that array here. So we have an array. The initial size is 16. So you can also specify the size while you're creating the hash map to have a bigger size. But here by default, the initial size is 16. So you have an array starting from index 0. And you can think of this array, right? It's a big array, 2, 3. And you think it runs till 15. Because we start from 0, it runs till 15. So it's an array of objects. That's what is created while you create an hash map. So how it stores these values? Say it takes the key. If I want to store 12BC001 and Satish, it takes the key. So this key is taken and then it is passed to a hash function. So you pass that to a hash function. So you hash it. So what is this performing here is it's just giving us an integer value. It gives us an integer value for this object you are hashing. It's an integer representation of the object reference. That is the meaning. Or else you can think of that to be an integer value that is getting returned. And next, what you're doing is you're taking the length of this array. What is the length of this array? N is 16. And what you're going to do is n minus 1. And you do a bitwise AND with the integer value that is returned here. So you're going to perform this. So it is done internally. That's what is happening. So n minus 1 here is 15. And a bitwise AND with your integer value. It can be any value like 15807, something like that. So when this operation is done, this will resolve to a value in the index. Say this is number 2. So now this points to a value in the index. So what happens here is in this index, there is an object reference created and an object is getting created. And this object is going to hold the hash value. What is the hash value? 15807. It's going to hold the key. What is the key? 12BCE001. It's going to hold the value Satish. So I told you it's an array of objects, right? So it takes the key, hashes it, and then it uses this formula to compute the index. From the index, an object reference will be pointing to an allocation on the heap. and a node is getting created. You call this node. A node is getting created, which will hold the hash value, the key, the value, and there's one more thing, the pointer to the next node. So this is how it stores. Likewise, you take 12 BCE002. What will be the process here? It will take it, it will supply it to the hash function, compute the hash, you will get an integer value. So you perform a bitwise AND of that integer value with n minus 1. Say it resolves to 14 or 15. Say it resolves to 15. Then what happens here? There will be an object created of type node. So this is an object of type node. And what will be here? Say if the integer hash value is 15999, something like that. And the value 12 BCE002, that is the key, and the value RAM. Okay. Suppose it wants to search for a particular value. Say I want to search for this key, Satish. I'm sorry. Suppose if I want to search 12 BCE001, how to search? How to search? So the user enters 12 BCE001. The array holds all these objects. How will you search? You take this key, again you hash it, you find the index, you find this key, and then the value, right? Say if I want to search for 12 BCE001, how will I search? I have created this structure, right? How will I search? Hash it. When I hash it, I'll be getting 15807. And then I'll compute this in this formula. I'll know in which index I have to find. So directly I'll go to index 2, and then I'll be able to check the key. If there is a key match, I'll fetch the value. You understood this concept? So what is the advantage of having hashed structures? You get a constant time based search, right? Your search is going to always be of constant time. Say, if whenever I want to search, I hash it, I am directly on that index which is pointing to that object. So you're not going to have a linear search here or binary search here. You're just going to hash it. Every time you're going to hash it, you're going to get the same value for this key you're passing. So you're going to go to that place and then you're going to directly fetch it. So for get and put, that is when you're putting something in the array or the hash map, or you're getting something from the hash map, the fetch and put time is constant. So that is the advantage when you compare with the linear search or binary search. This is better. But what are the disadvantages you may face here? Or what kind of problems you may face when you have this kind of an architecture? I told you, you take a key and then you pass it to the hash function. You get some integer value out. Say you get 15807 the very first time. So is it like if I pass any other key, can I get the same value out? If I pass any other key, say by chance 12BC0004, if I pass it to the hash function, will I be able to get the same key out? I mean, same integer value I have received for the other keys. The other way to put it like this, if you hash two different keys, is there a chance of getting the same hashed value? How many of you say yes? Yes, only a few of them are saying yes. What do you call that? When you get the same value, you call that a collision, right? Let me go ahead with this scenario. Let me explain this. Let me take an eraser. What I'm trying to say here is collisions are possible in hashing. I'll explain you how collisions are possible. And say you take another key, 12BC004 corresponding to Tom. You want to hash this. Say I'll hash it. So hash, I'll pass this 12BC004. So this is a new value. And when you use that in a hash function, there is always a possibility that you will get 15807. So this hash value you have already received for 12BC001. So in hash function, there is a possibility that two different keys can hash to the same value. That is a possibility. So now when you use it in the index n-1 and you do a bitwise AND with this value, what it will result to? 2. So when it resolves to 2, it points to this index 2, right? So now what it does is it comes here and it checks whether there is already an object present. There is already an object with the same hash value, right? So there will be an object. Now what is that it's going to perform is, it's not going to do anything here. It's going to create a pointer from this node which you have already, it will have a pointer and another node will be created that will be pointing to this node. And then the hash value 15807 will be here. And the key is different. What is the key here? 12 BCE4. 12 BCE4 is the key and the value is Tom. So this is going to be again a chain, a linked list of nodes. So this is a linked list that is actually getting built up there. So when you're searching for 12 BCE004, what will happen? It will take that, hash it, compute this formula, go to 2, and then now it will do a linear search starting from 12 BCE1, it will jump to 12 BCE4, check whether the keys match, and then it will return the value. So that's how the hash maps are maintained internally in Java. There is one more concept we have to learn. While we created this hash map, what is the initial size of this array? 16. And you can also mention a loading factor. There is something called load factor, which we give while we create a hash map. So what is this load factor? If 75%, if I give 75 as the load factor, 0.75, it means when my array gets filled for 75%, when it gets filled for 75%, the size will be doubled automatically. The size will be increased to 32. So it will be just going in multiples like this, 16, 32, 64. So that is called the load factor. While I'm creating an hash map, I can mention the size. I can also mention the load factor. So load factor, what it says, when 75% or 65%, whatever load factor I'm going to give, when it achieves that load factor, the size of the array will be automatically doubled. So increase the size. So that's about this theory. I hope you are clear with how hash maps internally store values and keys and what are the advantages. Now we have to understand what is this hash code and can we compute an hash code? You can compute hash code for any object that you create. For instance, you have a string k is equal to some value. Now you can create this hash code. Hash code is an method in the object class. So how will you create this hash code? Let me just type it out. It is nothing but k dot, hash code. So we are just creating an hash code for this particular object I have created. K dot hash code will be taking this and converting it to an hash code. So this is what we are seeing. We take the key and we convert that to an hash code, right? So here, what will be the value that is going to be shown when you create this hash code? So you'll see some integer representation of the reference. So you can see here, that's what I was telling you, 15807 will be created. So you're getting some integer reference here. And how you compute the index, you do n-1, a bitwise AND with this hash code. So our initial size for the index, our initial size for the array is 16. So n-1 is nothing but 16 minus 1. So we'll have 15, right? 15, you do a bitwise AND with this hash code. So that is the formula to compute your index in the array. So what will be the output here? Let's check that. So this should be something between 0 and 15. So let's check the, so it shows us 2. So now it goes to the index 2 in the array and then an object of type node is getting created. There will be a reference from index 2 in the array to that particular object called node. So I told you there is an object of type node getting created. Object of type node getting created. So when I say there is an object getting created, what should be there? There should be a class, right? Only when you have a class, you can create an object. So where is this class? When you go to the source code of HashMap, and then when you search for node, node is actually a nested inner class in HashMap. So this is the static nested class node. And you can see, well, what are the attributes of this node class? You have the hash value, you have the key, you have the value, and then the pointer to the next node. So it is going to create an object of the node in the reference to. Got it. And if you have another key hashing to the same index, this next is going to point to that node that's getting added in the linked list. So that is hash map. And when you take a look at hash maps, it's nothing but an array of objects. That's what is the source telling us. I'll just show you this definition of hash map here. Where is that? What happens when I create node? So again, there are certain things that we have to understand. Yes. So I told you the default initial capacity is nothing but 16. That is 1 left shifted by 4. So you get the value 16. And what is the maximum capacity? 1 left shifted by 30. It's a very big number. So that is the maximum capacity you can give while you are creating this hash map. And the default load factor is 0.75F. That is, when 75% of your array of objects get filled, your array size will be automatically increased to double the size. That is, these are certain things, and you still have other things which you can, if you are interested, you can go through that. Okay, so now let's take a look at certain examples of how to create an hash map, how to populate this key value pairs, how to get the key value pairs, and all these things. So how will you create this hash map? You have to create a new object of type hash map. And there is k comma b given here. What you have to mention here is what is the data type for your key. The data type for my key is string. Say I'm going to store registration number and names. And what is the data type for your value? That's again a string. And I'll call my hash map to be student. That's the name I'll give. And here, if I don't mention the size, automatically 16 is the length of my array. If I mention the size, then I can mention the size, comma, the load factor 2. And these are two different constructors inside the hash map class. Now, how to put some values, key value pairs inside my hash map? I call student dot put, and you just insert the key. Key is nothing but, say, let me give the value 12BC001, and value is Satish. So I'll enter my name here. Okay. Likewise, you can put some more records. I'll just copy paste this. Can't have duplicate keys. 2 and 3, and then let's say it's Jeff, and we'll call this Ram. Suppose in case if I try inserting a duplicate key, what will happen? Suppose if I try inserting a duplicate key like this, and then say I have some other value, Tom. Now what's going to happen if I insert a duplicate value? So it's going to create the array and it will start populating the nodes in the array, right? So once when it comes with this key, it will hash it. It will go to the corresponding index. It will find there is already a key with the same value. I mean, there's already a key that is 12BC001. So what it will do is it will just override, say it will just override Satish as Tom. So it's not going to add a new node for the same key because duplicates are not allowed. Please understand that. So when you try inserting a duplicate, it will just override this value for the existing key. So we have put, and if you want to print all the data from the hash map, what you can do, this out, and you can just call the name. This will just print all the value key value pairs. You can see there. So this is the key value pair inside your hash map. If I want to get a specific value using the key, how can I perform that? I can perform that using dot get. So I'll use student dot get, and then I'll pass the key. So I want to pass the key as 12BC001. So what will be the answer here? 12BC1, the value will be printed. Let's check what is the answer. So I pass the key. I should be getting the value out for that key. Okay, so you can perform this, and you can also check whether there is a certain key or a certain value inside the hash map. But before that, we have the standard methods that we are used to. You know what this does, right? Student dot size is going to print number of elements in the number of key value pairs in your collection, and student dot clear, what it's going to do. Student dot clear will clear all the key value pairs from your collection. And student dot is empty. What it's going to do is going to tell us whether the collection is empty or not. So these are some standard methods which you have applied across various collections. Okay. There are other methods too, like student dot contains. I can just perform this. If student dot contains key 12 BCE 0001. See, I'm searching the entire list of nodes here. That is whether any of my nodes contain this key. That's the concept. So I can say element is found. That's it. Element is found. So what it does, it's going to search the entire array, all the nodes to check whether there is a node with that key. Now, when you run this, you're going to say element is found. If it's not found, it's going to say element is not found. So you can check contains key, whether there is a key of this kind present. So what is the use of this method? Checks whether a key is available. So you also have one more method for searching values. So I think there should be something like contains value too. So is there a value by name Satish in my entire HashMap? So you can also check that. Okay. So this is with respect to searching an entire HashMap and saying whether it is available or not. Suppose if I want to find a student whose registration number is 12BC001 and I want to print his name, then what I should do? I want to search for a registration number and then print his name alone. So now I have to iterate through every key value pair, find whether the registration number is 12BC1 or 2, and then print the corresponding name. How to iterate through this hash map? For this, I'm going to perform this. I'm going to fetch all the strings from student.keyset. So there is a method called keyset, which will return every key. So it's going to take every key and return it to the string. So key set, it's going to get all the keys and return it as one key at a time to my string. So I can just print sys out. Here I can just print s.get. I mean student.get. It's not s.get, student.get. And then you pass the key. Now what's going to happen is it's going to fetch every key, pass it here, and it's going to print the name for that key. So you can see this here. Ram, Satish, and Jeff getting printed. How it happened? This key set first took 12BC001 and then it was moving it to string S. When I do dot get of S, it was printing the name using that key. So S was getting the key every time in this iteration. So this is one way to perform, traverse through this hash map. It's a very simple way. There's one more way which is extensively used. I'll also show that. For that, we should call some two different methods and we have to perform this. That is we have to use map.entry. And let me not have this. We'll use map.entry and then we'll say what type of key value pairs we are going to get. It's going to be string and string. And this is going to be a key value pair that's coming in. A key and a value pair will be returned when you call student.entry set. So what is the job of entry set is to traverse your hash map and then return the key and value pair together to map.entry, which will hold a key value pair at a time. And how will you print the key value pair here is we call the object. What is the object we have here? K. You call K and then you do k.getKey. That will print 12BC001 for the first record. And then you can also print k.getValue. So it's going to print k.getValue. So for every record, key value pair is written and then key and the value is getting printed here. So you see, first you get the key, next you get the value. First you get the key, next you get the value. So this is another way And there are other ways too. You can also use iterators to iterate. And you have more number of ways to traverse an hash map. But if you understand this, that's fine. So now the question is how to find students or else how to print only the name for the student with the registration number 12 BCE1. How to perform that. So I'm able to get all the key value pairs. I can now check, right, if k dot get key dot equals or contains whatever it is. I'll do contains 12 BCE 0001. So if this key contains this, I can just print the output, right? What is the output? That is student dot. It is not student dot. It's k dot get value. For that particular object, what is the value? Because that particular key has got this thing. And once when I find what I can do, I can always set my flag to false. No need to go ahead and check a flag to true here. And I can break from this for loop. Because keys cannot be duplicates. No need to iterate through the array once when you have finished finding the match. And what is this Boolean? As usual, I'm going to have this Boolean flag set to false. Found is equal to false. And what is the use of this Boolean? I'm not going to iterate the array or the hash map. I'm going to break out of it. And after I come out, I'll just check if not a found. We'll say the student is not found in the hash map. That's it. So we'll run this. We'll check whether we are getting our answer. So it should be the name printed. Satish should be printed here. Yes. If you just give someone else, say 12 BC 11 or something like that, and you search, you should get the student is not found in the hash map. So that's how you use an hash map. There are other methods too. I'll just check what other methods we have. Replace is there. Contains key, contains value we have seen. Remove is there. What is the use of remove? What is the use of remove? You can remove a specific node by using the key. So how will you remove student? I want to remove Satish out. So student dot remove. Always use the key. What is this? 12 BCE 001. That's going to remove my object out. And if I want to replace Satish with some other value, 12 BCE 001, I want to replace that Satish with say Tom. What I have to do here is I have to do Satish dot replace. And I can give the key. What is the key? 12 BCE 0001. 001. And what value I'm going to replace that with? I'm going to replace that with Tom. So this is going to replace Satish with Tom. And we'll just print all the key value pairs here. That's it, to check if this is working. So we'll just print this out k dot get key, and then so you can see there is this 12 BC 001, which was replaced as Tom, which was earlier, that was Satish. So there are again lot of methods in hash maps. You can explore that on your own, but you should have got a very good understanding of what an hash map is, what a hash code is, what is the initial size we offer, what is the load factor we give. And next, the very important things you have understood, the various methods, how you traverse the hash map using the key set and also the entry set, such things.